Welcome to Rational Expressions. We're just going to jump right into it. The quotient of two polynomials, p and q, where q does not equal 0, is a rational expression, p over q. So all this is, two polynomials in both the quotient and the denominator, as a quotient in both the numerator and the denominator. So an example would be x squared plus 3x plus 1 divided by x plus 1. That is a rational expression. Rational essentially means, well, in a way it means fraction, if you think of it in that sense. It's a number that can be written as a fraction. So there's just an example. Things you'll want to do with rational expressions, here's one that your homework will ask you to do, is write in lowest terms. So essentially that means simplify. To simplify something like this, we're going to need to factor it. So first we're going to work on the numerator, 2x squared plus 7x minus 4. So if we have 2x squared plus 7x minus 4, I'm going to factor this using the AC method. We have AC is equal to 2 times negative 4, which is negative 8. Factors of negative 8 that add to 7 are going to be positive 8 and negative 1. So 8 plus negative 1 is positive 7. So we're going to rewrite this as 2x squared plus 8x plus, I'm just setting a plus there, plus minus 1x minus 4. So 8x minus x is 7x. So then we're going to take our groups like that. Factor out what we can. 2x squared plus 8x, we can take it a 2 and an x. So we're left with x plus 4. And then here we can take out a negative 1. So negative 1, x plus 4. We notice that x plus 4 and x plus 4 are the same here and there. So we can rewrite this as 2x minus 1 times x plus 4. So we've successfully factored the numerator. And the denominator, we can actually take out a 5 and an x. So I'm going to rewrite this here using the factored form of the numerator. We have 2x minus 1 times x plus 4. And factoring out 5 and x from the denominator, we're left with just x, and we're left with plus 4. We notice that we have x plus 4 and x plus 4 on the top and the bottom. Now remember, whenever you have something that itself, so if you write it like this is just going to be 1. It doesn't matter that there's an x in it, because this is the same on the top and the bottom. It cancels each other out, and it's just going to be the number 1. So when you multiply, you can essentially cancel these two things because there's multiplication in between them all. If there was a plus or a minus in between, then you can't do that. Just making sure. And so you can rewrite this entire thing, after canceling this, as 2x minus 1 divided by 5x. So that's this in lowest terms. Another example is 6 minus 3x over x squared minus 4. We're going to factor these. So 6 minus 3x, we can take out a 3. We are left with 2 minus x. And then on the denominator, this factors to x plus 2 and x minus 2. Now at first you may think, hey, none of these are alike. However, we can actually switch this 2 minus x to x minus 2 by factoring out a negative from 2 minus x. So if we do that, if we factor out the negative of 2 minus x, we're left with negative 3. I'm just putting the negative 1 to the front of negative 3. Times, factoring out a negative 1 from a positive 2 is negative 2. Because if you think about it, negative 1 times negative 2 is positive 2. Factoring out negative 1 from negative x is positive x. Over x plus 2, x minus 2, moving down. And we can rewrite negative 2 plus x as x minus 2. And now we notice that we have the same factor, x minus 2, on the top and the bottom. So, and it's all multiplication in between all the factors, so we can cancel that because having it on the top and the bottom is just 1. And so in lowest form, this is, or lowest terms, this is negative 3 divided by x plus 2. So those are two examples on how to write in lowest terms. Next thing you can do with rational expressions is, well, add them, just like what we did with fractions. And we have to do the same thing with rational expressions as we do with fractions. If we add, they need to have the same denominator. So what we need to do is need to find the LCD, the least common denominator. So one way to find the LCD is reduce to all of the prime factors. So the prime factors of 9x squared, I'll just rewrite this here. Prime factors of 9x squared is 3. 3 is a prime factor because it only has the factors of 3 and 1, of itself and 1. 3 times 3 is 9, and then times x is x squared. And then we have our 1 over 6x, reducing 6x to its prime factors. It's basically reducing to as much as we can get. 6 is 2 times 3 times x. And we're going to take all the unique factors of the denominators and multiply them together to find the LCD. So here we have 3 times 3. There's already a 3 here. So we don't have to multiply 3 times 3 times 3. We just keep 3 times 3. And we have 2 x's here, so we have to keep those 2 x's. And here we have a 2, which is unique. So 3 and x are already in here, but the 2 is not in here. So we need to add the 2. So if we have 3 times 3, we probably should have put the 2 over here. But 3 times 3 is 9, times 2 is 18, times x, which is x squared. So this is our LCD right here. So we need to manipulate the denominators here to get 18x squared. So what we multiply 9x squared by, so we have the fraction 5 over 9x squared. To get 18x squared on the denominator, we need to multiply 9x squared by just 2. But if we do that, then we get 18x squared. But we don't want to change the value of 5 over 9x squared, so we need to multiply by 2 over 2, which is 1. So doing that, we get 10 over 18x squared. Now we have to do it to the second one. So 1 over 6x, we want to make 6x into 18x squared. So to make 6x into 18x squared, we first need to multiply this 6 by 3 to get 18. And we also need to multiply by an x. And if we do 6x times 3x, we get 18x squared. We don't want to change the value of this function, so we have to multiply by the same thing on top and bottom. 3x over 3x is 1. So doing that, 1 times 3x is 3x. 6x times 3x is 18x squared. So now that we've rewritten them with the same denominator, we can rewrite it over here as 10 over 18x squared plus 3x over 18x squared. So these are equivalent fractions to what was up here originally. But now that they have the same denominator, now we can simply add the top. So this is 10 plus 3x over 18x squared. And that's as simplified as you're going to get that. So that's how you can add some rational expressions. Here's another example. So at first they don't have the same denominator if we're going to add them. However, we can factor out, just like we did in a previous example, a negative 1 from this one to actually get the same denominator. So if we take 2 minus y and we take out a negative 1, we take 1 out, right? We take 1 out. Then we're going to get a negative 2 and a positive y if we factor out a negative 1, which you can then write as -1 times y minus 2. And if you have a -1 factored out of a fraction, you can actually move this negative up to this 8. So this is the same thing as y over y minus 2 plus, and I'm moving the negative up to the top, negative times 8, which is just -8, over y minus 2. Now they have the same denominators, so we can rewrite this as y minus 8 over y minus 2. And that's as simplified as you're going to get that. So next we want to subtract. So subtraction is the same as addition. We need to have the same denominators. We'll notice that we have essentially all these different types of factors. We have x minus 1 times x plus 2. We have x plus 3 times x minus 4. So the LCD, because none of them are unique, I mean all of them are unique, none of them are the same, is just going to be all of these 4 factors multiplied together. So it's going to be x minus 1, x plus 2, this is also being multiplied, times x plus 3 times x minus 4. So we're going to multiply this LCD. We're going to make it so the LCD is on both the top and the bottom. So doing that to the first fraction, we have 3 over x minus 1 times x plus 2. To make it have this LCD, we need to multiply it by these factors right here, x plus 3, x minus 4. But we don't want to make it be different, so we do it over itself. And so this is going to be the fraction of 3 times x plus 3 times x minus 4 all over, and since it's a really long fraction, it's x minus 1, x plus 2, x plus 3, x minus 4. I'm just going to write LCD, so whatever the LCD is. And then manipulating the second fraction here, we have, I'm just going to put the negative there, x plus 3 times x minus 4. We need to multiply it to get the bottom, the LCD. We need to multiply it by its missing factors of x minus 1 and x plus 2. But we don't want to change the value of it, so we have to put it over itself, x minus 1, x plus 2. Like that. So this is the same thing as -1 times x minus 1 times x plus 2 over the LCD. And so rewriting this is a lot of words. So we have 3 times x plus 3 times x minus 4 over the LCD plus -1 x minus 1 x plus 2 all over the LCD. So we can rewrite it like that. Now we can add these two things up top. So this is 3x plus 3 x minus 4 minus, and you can x minus 1 x plus 2 all over the LCD. So it's very long, but that's how you would do a problem like that. And this problem is exactly the same as your participation problem number 1. So if you want to go and do that and then turn it in to me next class period, I can give you 40 extra bonus points.